I have a couple questions we're going to go through relating statements about space-time diagrams. So graphs of position versus time and interpreting what those graphs are telling us. So this first question, I have a train car moves along a straight track. The graph below shows the position as a function of time for this train. The graph shows the train. Is it speeding up all the time? Is it slowing down all the time? Speeds up part of the time and slows down part of the time, and moves at a constant velocity. So think it through, talk it over with other folks in the class if you can, and then when you're ready, resume the video and see what the answer is. Right. So this is showing a case where the train is going slower and slower all the time. I keep laying down lines that are tangent to the curve, the slope of that line is getting shallower and shallower and shallower. Okay, so this is slowing down all the time. If we were speeding up all the time, the slope of the tangent curve would have to be getting steeper and steeper and steeper and steeper. That's not what we see. And it is not speeding up part of the time and slowing down part of the time. It's only slowing down. If we were moving at constant velocity, then the graph of position versus time would be a straight line. Okay, so it's not that. All right, let's try another one. Graph below shows the position as a function of time for two trains running on parallel tracks. Which of these statements is true? At the time TB, both trains have the same velocity. Both trains are speeding up all the time. Both trains have the same velocity at some time before T sub B, or is 4 true? Somewhere on the graph, both trains have the same acceleration. So from this space-time diagram, look it over, think about what those graphs are telling you, and then evaluate which of those 4 statements is true. Think it over, talk it over with a physics buddy, and then when you're ready, start the video back up. All right, so the one that is true is that at both of those trains have the same velocity at some time before T sub B. Basically, it's going to be right about here, this time. Because at that point in time, the slope, which is constant for train A, matches the slope that's tangent to the curve of position versus time for train B. So at time TB, both trains have the same velocity, not true. The slopes are not the same. Both trains speed up all the time, not true. Train A keeps a constant velocity. Somewhere on the graph, both trains have the same acceleration, not true, because train A has no acceleration. Its velocity is constant, it's a constant slope. All right, so the only one that's true is that both trains have the same velocity at some time before T sub B.